Hello everyone, welcome back to my channel. So as we discussed, we are going to continue to solve the exercises. We have some problems, and here, for example, first question is how to merge the data set. We already mentioned that, but I have these questions, and we will go one by one, and we will make some visualization. At the end, there's a bonus. For example, you're making some visualization about data in different parts. For example, right now is we are working with the snow and ice removal data, right? So for example, let's say we are looking for which cities spend most money, which cities has most deficit, which one is spent uh, most, snow and ice removal expenditure per resident or per mile. So these are giving different cities, right? For example, we are seeing Boston in somewhere, we are seeing another city in other data. So at the end, we are going to create some kind of score. So we can just one score, we can just somehow use all those different metrics like expenditure per mile or expenditure per person. We were going to divide the population. So let's continue here. As we can see, I just already, for example, I am keeping this clean data because as I mentioned, we are going to create a database using PostgreSQL. Then we are going to connect that database using Power BI, and we are going to create a really cool dashboards. And I will explain that one in the other video. So, okay, so now I'm reading that clean data, okay? So now I'm joining those data sets as it's really similar to SQL function. We're just joining these two table on this unique identifiers and how it's inner. So we want to do inner join here. So let's look at our data sets. Everything is clean. Now we don't have to deal with the clean or fix some issues in the columns. Let's check the shape. Everything looks fine. So which county spend most on snow and ice removal in 2022? So I mentioned here, I previously created total expenditure column by expenditure to appropriation and minus the state and federal reimbursement, right? So we are going to use that one. So which county spend the most on snow and ice removal? How can we just make this? So we are getting counties and we are going to sum total expenditure, right? How can we do that? We can group by those our data sets by county. So we were getting counties and then getting all those expenditure summing for each line, right? So how this group by works. So what we are doing here, so master DF group by, we're getting county, then summing the total expenditure for each county. And what happens here, after summing it, let me show you this line of the code first so you can see what I mean by that. So as we can see, we are seeing we are seeing our data sets group by county and seeing the total expenditure. For example, how can we get it? For example, which ones spend most on snow and ice removal? We can just order this data set, right? We can just sort them and just get the first one because this one is still a table. So you can get the first element, then that will be the county which spend uh, uh, on the snow and ice removal, right? What I am going to do here, ID max, how this function works, it's getting these values here and it's getting just the maximum one. Let's say this one is maximum one. Probably, I don't remember which one, but probably this middle is, yeah, this one is the max one. It's getting the ID of that max value. Let me show you real quick here. What does that mean? It's just getting that max value and it's giving us that its ID. That's what I am using. I'm showing the different perspective and some functionalities you can use. I'm just using another style at below other question. I will show that one. And then when I just get this one, for example, this one is the now ID of the county. Now we are getting the max. This is the amount. So we can get it. For example, let's just give us an ID as I mentioned here, right? So Okay, what is the IDs here in this table? These are the IDs, name of the counties, right? So the maximum, using the max value will give us the max value of this expenditure. We can give a column name here, but we don't need to. We were just now at the end, what I am doing here, we're using printf, and using this printf, the county that spent most of, I'm just making, readable using this printf and the format options. This means, guys, it just shows your number like this. If we don't use this one, it will be just, like this. It's not readable, right? Just I'm using this one here to better readability. Okay. So okay. So which municipality spend most per road mile on snow and ice removal? First of all, for municipalities, we can't group by, right? Because municipalities are unique. We have 351 municipalities. So what can we do? First of all, what we need to do is ask us to per road mile, right? What we can do, we have to get total expenditure and divide it to city down accepted. We mentioned in the notes before, if you guys watched the previous videos, we are going to only use the city down accepted because these are the only municipalities responsible in these miles. So we are getting each one using this one method. It's just pretty intuitive. We are just dividing the total expenditure to city down accepted. Then we are getting the expenditure per road mile, right? So how can we get the maximum one? So basically like this, we are getting again using the log functionality of the pandas data frame. And what it does, let me just run to you. It just gets us the max ID. Let me show you real quick here what it shows us. As you can see in our data set, which municipality has spend most per road mile, which is, for example, this one is each value of that, each road value of that municipality. Which one is in, dear code is 35, Boston, Suffolk. But this one, the answer is Boston here, and we are seeing that. So again, we are using the printf here, print municipality with the highest expenditure per road mile, and we are getting municipality name out of it as I showed above, and then we are getting our new column expenditure per road mile, and we are printing here. Okay, so these are really intuitive. So then other question to see which municipality had largest total budget deficit for snow and ice removal. So we have deficit reported on the balance sheet, right? We controlled it, we checked it, and the values are correct before the previous videos. So what can we do? And we are looking for municipalities again. As I said, municipalities are the unique values in our data set. We don't need any group by or anything like we did in counties. For example, if this is asking for the counties, we have to group by because they're not unique and there are multiple ones. If somebody is asking this kind of question, if there are multiple values for different counties, you have to group by. But now they're asking the municipalities, they are unique values. We can just basically sort them, right? We can sort them. Lowest one, the bottom one is lowest one. We are doing here, for example, master DF sort values. This is another pandas functionality by deficit reported on the balance sheet. You can just easily put here whichever column you want to put, and then ascending through, and I'm getting the first one. As you can see here, let me show you this code, how it works. Whatever you don't understand code, just split it, right? How does it work? For example, this is a really easy functionality, but you don't understand, right? How does this work? When I removed it, see, I'm seeing the old data set. What I need is just this value is sorted by that column. When I just add that functionality, and I can understand what it does, right? It's just an intuitive. If you understand how this functionality works, then after that you are asking, hey, how can I solve this question? Just Google it or ask the LLM model. I think the programming is just changing like this. So as we can see, again, Boston is the municipality has largest total deficit for snow and ice removal in 2022, and we can see that how much their deficit. So anyway, so after this one, we are getting the higher deficit. So this is what it is. So head one, we are getting the one line, one row. Then we can get the values, right? Municipality, we can get the, so what is that? High deficit municipality. Let me show you. This will give us the Boston, right? Sorry, I didn't run this code yet. So that's why we are getting an error here. So this Boston. So if I can say, if I want to get the index, it will give me this, but I need a value, right? It will give me the name of the Boston, so I can use that value in my printf. So max deficit amount, just intuitive. What can we get? Deficit report on the balance sheet and values again, and just run it, and you will get this nice looking and printed values here. And Boston and total deficit was this amount. Okay, so you can, as a bonus, you can functionalize this um, this problem here. So for example, there are some projects you are using again and again, right? There are some questions. Writing same code is not make sense. It's not programmatic. So you can just write some questions like I did here. Find largest deficit by municipality. So what I need, which one is the deficit column? I am going to give the data frame, right? And deficit column and adding the same functionality. Look, when I just write this functionality, now there's just one line of code. Whenever, let's say the data is come from the 2023. So when I run this one line of the code, and it will give us just with one line of code, we will get the same result, right? In the future, let's say next year data again. So are there any question we had interested? So for example, which municipalities made supplemental appropriations and transferred for snow and ice removal and still had a deficit? So this is another nice question. How can we find it, right? So we are getting from our data frame, supplemental findings, snow and ice, right? And greater than 0, which means that municipality made supplemental appropriations for snow and ice removal. And then what I'm saying, and I'm just sorting them by, again, like we did before with the deficit reported in the balance sheet, and ascending through, and I'm saying that this is supplemental budget, right? Then what I am doing here, supplemental budget, but deficit, how can I do that, right? So after getting this supplemental budget data frame, what I am doing here, which ones are less than 0. So then I am printing those values, right? So we can see those municipalities. In this case, we have multiple values. By the way, I'm not writing the code because it will take time, right? I know some people just, looking at the screen writing this code. But if you guys are watching, some code, if you guys seem, a little bit complicated, if you don't understand it, you should write those codes. That will help you improve your skills. I wrote those one by one by myself, but now I explain everything. So I don't want to write it again because it will take more time for me to do everything. So we have multiple values. What it does means, for example, so that's why as a data analyst, you need a visualization. You have to visualize this data, not just the ordinary visualization. You have to somehow sort the values. It will make sense to your, let's say, executives, whoever is going to see your data set, right? If you just visualize this data, for example, let me just explain this code. So this is a function, def at labels, what this function does. This function get X here. Let me just after I will explain this part after I'm reading here. So PL to figure, and if you guys know the matplotlib, this is just to give you a figure, and you are getting your first access and second access, and then you are getting your bars. Let me show you one by one, right? So for matplotlib, you should just look at the things. Let me just Let me should say that PLT that shows, sorry. Uh, okay, so why I didn't get, because I didn't put the values. Anyway, let me just explain you one by one. So it's this one is gives you let me just run it again. Let me run it first. Yes, we don't have any problem. So what it does, so first of all, we are getting the figure. This is the fixed size. You can just change it, depends on your need. So the 12 to 8 here. And so I'm getting the number of bars. So how many bars I have, right? I'm going to use this value in the future. So I'm just getting the land supplemental budget, but deficit municipality. So how many municipality I have. These are the bars I have in the future. So I'm getting the index. So I'm going to put an index for each bar, right? This what I am doing, mp.orange, what it does, getting those number of the bars and give me from 0 to until that final value, right? 1, 2, 3, 4, 5, if I have 6 bars, right? So 0, 1, 2, 3, 4, 5. So it starts with the 0. Then you can arrange the bar width here, and you can put the offset again the between the bars, the between these 2 bars here in this offset width. So what is that? We are putting the label for this bar in the, for example, it gives the this for X label. So our X axis here, municipality, right? So this one is the Y label. This means Y label here, supplemental funding for deficit amount. Just putting the dollar sign here so people understand what are you talking about, right? So just adding these explanatory values will help the reader or your manager or executives, they will understand what this data about, right? So they don't know that that this data set. So then you can give the title with the PLT that title, and it will put it here. You can even arrange that one. So text. So what is our text, right? Texts are this part, guys, the bottom part. So what are that? So we are getting the indexes. So we put these indexes, right? So MP arrange that bars. These are our indexes, right? So these were our indexes. For each index, what's going to happen? Where were we? Yes, here. So yeah. So where was I? Yeah, supplemental absolute values. I checked this one. So text, and so for each index, what I am going to give for each index, this values. So right. So these were my index. So I'm going to put these values instead of this index in my text values, as you can see here. Okay. So for each, they're in order. So I'm going to give those values. So then what's happening here? So these are my Y values, right? Supplemental budget deficit reported in the balance sheet. I'm getting the absolute values, and the second value is supplemental funding and snow and ice. So what I want to do, I want 2 Y values in my graph. One is the deficit reported in the balance sheet. There minus, because this is a deficit, you will see the negative values. So I'm making absolute so we can see then getting the second one, the supplemental. So for example, and so I'm adding this legend here. So this one is our deficit. This one is the supplemental appropriations for that. Then so you can arrange your y ticks here, depends on your data, and I put this one. So what we are going to do, just put those positions, right? So the y tick labels. So this is PL2 y ticks. These are the positions like we did here, right? Index 2 and the municipality array names. Now, and then I'm adding the legend. So legends are these ones, right? Deficit. And then I'm adding the labels. So what this labels does, I'm giving this each index, right? These are the labels, guys. Okay, these are the labels. Don't forget these ones. So I'm giving those Y values as a label in my each for my bar. So how does it work? So at labels, getting these indexes, I'm adding those offsets here, right? One of them is just giving plus because it's just a different part. So what it does is gets those index and offset and the y values. So we are enumerating each height. What are our each heights? Heights are our y values we are going to show here. So we are giving that label. So, okay, what is the height? And we are giving those good observation, to readability. We are just formatting them and adding each them as a text in our graph. So what it does here, it makes the for loop. We are going to see those heights. What are those heights? Our y values, and then go to our table and just find that height, right, each of them, and just put this amount distance and add those labels, right? So what are those labels? Our heights, and which is a little bit formatted. So as you can see, for example, if you can change some stuff, if you guys didn't understand, I'm going to share this code. For example, let's say this one is one. If I run this one, these ones will be more closer, right? So this one is like that. See, these are much more closer to our bars, right? These are the functionality of Matplotlib. It's really intuitive. You will get used to it. You can add different things. For example, we are adding these labels as text, but you can add many things. So, okay, this one is a little bit ugly. Let me change this one here because I'm saving this one, right? Okay, this one is good. Let me run it again. Okay, the other question is top 10 municipalities with large deficit as a proportion of their total budget. So how can we, so let's do it again. Top 10 municipalities, we will get the municipality with large deficit as a proportion of their, so deficit proportion on regarding their budget. If this is the question, what we're going to do, we will get our total budget, and then we will first we will divide the total deficit reported on the balance sheet divided by the total budget, right? So then we will get the top 10 municipalities. How can we get it? So we can just, after we dividing those values, as we mentioned before, municipalities are unique values. We don't have to make any group by or anything. We can just sort the values and we can get the top 10 values. How can we use? We can use hat functionality of the data frame. I will probably did it here. For example, what I'm doing here, as I mentioned, here I'm just dividing this value, deficit to total budget. What I am doing here, and I'm just only getting these two values. These are, I don't remember what we call it. It has, I think, fancy indexing. If I remember correctly, I'm getting these two columns from my data frame. Then I'm sorting values by using total deficit ratio. Where does the total deficit ratio come from? We created this column new, just here, right here, and then ascending, and we are getting the top 10 values here. So just let me show you. These are the top 10 ones. So again, we have multiple values. What can we do here? Again, just visualize the data set. You guys understand this one? Add labels. We were getting. I don't want to, because it's just on the differences. This function doesn't have indexes. Like here, right? Okay, we don't have any X values. Why is that? Because we don't need them, because there's just only one values. Let me just run it. As you can see, so we were getting those values and they're ordered, right? So we are adding those values here. So again, guys, so we have add values function. We are just getting, again, same size figure and y values. What are our y values? Total budget deficit ratio, right? So then what we are doing, and we are adding our bars, right? What are our bars? PLT.bar. We're getting each municipality and y values, right? Then what we are doing, these are our X label. That means the bottom is a municipality, and Y label deficit budget ratio. This is our titles, and we are adding those bars using our function, right? Labels, we are adding our labels. These are our labels, 6.28. Then after that, we are just showing our figure, right? Yeah, we allow it, just like this. If you guys didn't understand anything, I can explain everything again. Okay, we add the values, and now the other question, 3A. Total and average expenditure and snow and ice removal by county. How can you calculate this one? So county is not a unique value like we did in municipalities, so we have to group by those values. So we will get total and average expenditure. How can we do that? We can make a group by, then get the total values, then we can average those values. So for this question, I assume question implied to get average expenditure by county. This can be explained. So I explained. So you can interpret actually this question in two ways. So this can be answered by summing total expenditure for our counties and dividing by the number of unique counties, which I included Power BI. Okay, I will show that. And so here I exclude both scenario, right? So so to see which county has the total expenditure, sometimes you should do some, checking, because sometimes you could make some mistake in your code. So just in case, I'm just saying that. So total expenditure by county, what I'm doing, as I explained, so I'm just grouping my data to by county and getting the total expenditure and summing the total expenditure after grouping them and sorting the values, right? Ascending false. Now that means, for example, if I'm looking for the uh, first five counties, I can just add here, add 10, right? And then that will be solved answer. So excuse me, I said five. So I can just say add five here and I can just run it, okay? Now I might get some problem because this wasn't the thing. Then for first interpretation, average expenditure by county, what I am doing here, so I'm grouping each county and summing their values, right? Then dividing the number of unique counties. For second interpretation, I can just group by the counties and just get the mean of to mean of the total expenditure. And let me show you how this functions and let me show you this one. So yeah, as you can see, oh, okay. So I think this one is understand. Let me explain again. So this question has two interpretations. So total and average expenditures, snow and ice removal. So to find for example, the problem is come from the average expenditure. So if you're asking, what do you ask? What's the question here? So if you are asking the average expenditure by county, what can you do? Get the total expenditure of each county. That's why we are just getting the sum of the expenditure because, right? Okay, let me show you this. When I say this, it will give me this, right? But if we are looking for total expenditure, average expenditure by county, right? We can add other sum here, so we can see that what we get when I add this sum here, I will get the total one. So, right, total all of them. Now, this is the all total expenditure for all counties. So how can we get to average expenditure for counties? That will be, I am going to get the number of the unique counties here, right? What is that? 14. Then I will divide this number to 14 programmatically what I am doing there, right? I will get this result. This means average expenditure for counties. But as I said, this is first interpretation. Second interpretation is I'm just grouping by each my data set by the counties and getting average of the total expenditure, as you can see. So their mean values, right? we are getting the average expenditure of the each counties. What it does, for example, for Essex, it will get its uh, expenditure for the municipalities in Essex, and then dividing it to how many uh, municipalities in the Essex here. So that's why I just included both of them here. So total expenditure by county, average expenditure within the county, that will be the better thing. Then what I'm doing is just getting the, and I'm just now merging this one using the county and total and getting the total and expenditure. Let me just show you this merged expenditure DF here. So what we have here, and county name, total expenditure for each county, and total expenditure. We are getting the average one now here for each country. For example, total expenditure for this county and average expenditure for each municipality within this country is this amount, right? So I'm going to make a visualization again, two bar. So that means now this is our we are getting bars. We have again at labels functionality here, right? So what we are getting again, another figure size, figure and axis, and then we were giving the bar width, and these are our indexes, and this is the total bar, and we are making another visualization here, right? So we were seeing here, and we have the legends here, total expenditure and average expenditure within the county. The Middlesex one is the, so you guys already know, we are saving the figure I mentioned the previous video. And what's happening here, these are the labels, these are the X label, these are the Y label. I should say here, I should add a dollar sign here for the understand. And I'm giving title here. What is X index and the bar width, right? What are the indexes here? We are getting indexes from the merged expenditure. So what it does here, Lan, we are getting the 13, right? Yes, there is a 14. Uh, these are the index, and 0 to 13, as we saw, this is our indexes like we are here. Then we are using those indexes, and for the label, what we give it the county name for each indexes with putting some distance each other. So these are the Y ticks. I'm making the rotation here. If I didn't make the rotation, these are will be instead of horizontal, they will be vertical, and there will be problem with the readability. These are the ticks. You guys already know the legend here. As I mentioned, these are the adding the labels. I explained this functionality above, and so on and so forth. Okay, so I'm making a few tests here. Uh, Yeah, so okay, I'm just testing, whether it's correct or not. So this is another. So whatever you do, just make sure everything works correct. Okay, we come to another question, which is top 10 municipalities with the largest expenditure per road mile. So what we're gonna do, and again, expenditure we already have. We already calculated expenditure per road mile, right? And we will just, for looking for municipalities, as we can again, we are going to use sort values functionality by using the expenditure per mile ascending tree. If we need a top 10, so we can get the first top 10 values using the head here, because it's still a data frame and we were just running them. So we will just make a visualization. What we need these labels, and these ones are the y-axis, which means our vertical axis, and horizontal axis, we need this one, name of the municipalities. How can we are getting the bars? So what are the bars? We mentioned before, our bars are the municipalities uh, and the y values, right? So what is the y values? Top 10 municipality expenditure. So we are going to, so now our bars is tuple here, because we are giving this tuple as a tuple here, right? So y values and this. So now then we are doing these are the then we are doing in that tuple we are doing uh, we are looking for the height. These are the this one is our height, right? Then we are looking for the label, and then we are looking for the label. Again, the label is will be our ratios here. Now let me show you this one again to make it more clear. This will be to top 10 municipalities. What happens here when we say this PLT bar, it will create a bar. Okay, this is how these are our bars now. This is how the uh, PLT.bar works. So then what we are doing, we are making a for loop through these bars here. So and then we are getting the bar that height. Okay, each maybe let me just show it like this. Oh, sorry. So not bar, it's bars. So, okay. So each for loop, and for example, in the first for loop, we are getting the height. And then which each height, we are just using this formatting the labels. As you can see here, let me just run this part. We are formatting the labels, adding like this here, right? On top of this. Then these are our heights, right? And these are the label, and we are adding the PLT that's text in our graph, and we are getting the bar that get X, bar that get width, right? And then and get X and get in, and this is a small calculation here, and then adding those labels, as you can see here, and the rest of is the same as well. Just I wanted to explain what it does means, and the bar is gets this one, we can get the label and the everything here, okay? So as I showed here, when I said the one here, we will get the second one, as you can see this value here, okay? Okay, this one is understood too. And then we put some, here we are observing that Boston is spending much more than any other municipality. It should be examined what's the cause of the higher cost spending per mile, per road mile, right? So, what we can get, the Boston has high population density and narrow streets because downtown is really old in the Boston, if you guys know the area, and it might lead to removing the snow somewhere else. High population because they don't have enough space, so they have to take out that snow outside of the downtown area. And high population in busy streets might require more frequent removal, right? And this kind of adding some your comments about the data and the problem might help as well. Anyway, so top 10 municipality, which is deficit per resident. Same question, and now we are using the resident. What we will get the deficit and divide it to population, and we will get the deficit per resident, right? And then we were just sorting those values, and then we will getting the first 10 values using the head functionality. Same thing and different column, right? And then print, and these are the our values. Like we need to use absolute values, otherwise we'll be really, again, we will calculating our bars using this one and adding our labels and giving the labels here and X and Y labels and the thing. And then we can see that, as you can see, the Chester as municipality has highest largest snow and ice removal deficit per resident, right? We asked the same question. Yes, yes. And for example, top 10 municipality with largest snow and ice removal per resident. This is our things. So, okay, so as you can see, we can observe with them. Interesting. And for example, yeah, Boston has a high population, and which is makes sense. These are the probably really low populated areas. Let me just look at their population. I'm just curious. Yes, they do have really, Chester They do have, look, these are still down except small, but they have small population as well. That might be why, and they have really high. They have some deficit in their budget as well. Anyway, so this is the bonus section. So to see, Chester has a high um, deficit for population, but Boston is per mile, so per road mile. So what we can do to see which municipalities, their performance is bad, so we can make a composite score. So what we are doing here, so I'm just dividing expenditure per resident here, just dividing total expenditure to population, right? So I'm going to use a Mi'kmaq scalar. So now, because we are going to use different values, and if their scale is different, to understand that will be, and creating that score will be skewed by the highest value, right? So just scaling those values using the Mi'kmaq scalar from the scikit-learn library of the Python will be great. And with this one, if you guys know the object-oriented programming, now I am creating an example from that object, so I can use it as like its attributes and functionalities, right? Um, Here, I'm getting the scored data, so I'm just copying my data set using another thing. Sometimes copy your data. It's really intuitive and easy choice. So you can go back and, for example, if you mess this score data, you can copy here, right? Again, and then restart again. You don't have to go all the way up. So I'm just using absolute values. Uh, so use it, absolute values make sense, negative values. So for score data, what I'm going to use, as I mentioned, I have problem to compare those values. One of them says Boston scored worse. One of them says Chester, other one says another place, right? So what I'm going to do, I'm using expenditure per road mile, deficit per resident, expenditure per resident, right? And then I'm going to use each values and calculate the score, right? And this is a deficit per resident. And this is, these are, I'm checking whether it's, because it seems all of them is zero, right? And expenditure per resident, expenditure. So as you can see, these values are really, they're not in this, not same scale, right? That's why I'm going to use min-max scalar, because otherwise these values are going to skew our score and it will make it harder to understand. That's why many of the machine learning libraries, before your training data, accept the tree models because they don't care their scale, but some linear regression or XGBoots, making scaling your data is a really good choice. So what I'm doing, and now I made using my scalar, and I'm saying fit transform, and it will scale my data to between 0 to 1. This is the default value, and you can change it. Yeah. We can check it's been a while, but we can check you should check the documentation. It's a really easy, you can say min-max, scalar, scikit-learn, and they do have really good documentation. You can just check it here. Yes, so we probably, yeah, this is explain how does it work, but yes, this is the default feature range. So you can change this feature range. Depends on your situation, but this one is really works fine for me. So as you can see right now, you are seeing our data there is now normalized and scaled actually. And now I'm just giving a column names again to understand, to normalize data. And they're in the same order. Scalar is not breaking the order. So that's why I'm just again the same order like we have here, right? And now these are our scale values. Now I'm going to create so what I'm doing here, normalize df.columns, and I'm just adding a new column name, right? Here, it's just adding a norm at the end for each data. So I'm just adding my score data to these ones, right? normalize the after column score data, and just I'm adding these ones as a column to my score data set now. There's this normalized data, and I'm adding this norm, the column name, so I can distinguish these new columns from my data. As you can see here, let's go right, must be at the end. Yes, expenditure per road mile, I do have here, right? And these are the normalized one, deficit per resident, but this one is the normalized well, right? As you can see, depends on the, for example, if it's, high value, it gets the highest value. If it's low value, it gets the, lower, for example. And these are the, as you know, the deficit is absolute values we are seeing, right? And this is the, where is the deficit? Yes. So for deficit, and you might see, for example, 53 to 13, it's getting, why it's getting, this one is getting smaller, why it's getting bigger, because it's, as you know, it's a negative values. That's why. Another one is the same as the expenditure. So yeah, as I mentioned, it's just looking at the values and just making it. Then what I'm going to do here, so to make it, I subtract normalized values from one before calculating the composite score, normalized present. So what I'm doing here, I'm just subtracting each of them from the one to before I calculate it, because it's the sum of them is up and sum of them down, right? So now what I'm doing here, score data and getting each column and just getting the mean value of them. So score data, now I have a composite score, and I'm just using all of these values and get the mean value. Let's just check it, right? As you can see, Chester gets the worst score, right? By the way, lowest mean, that's why I subtracted one here. And lowest means as a bad score, and the highest means is this good score. And let me just visualize this data. Same methods, same functionality, right? I'm just not using to function instead of function. I'm just directly using it. As you can see, these are our composite score. That means we can say that, hey, Chester is the worst performance municipality. Boston's the second one, saving this third one. So you guys should just look at these municipalities more carefully, so on and so forth. Thank you so much, guys, watching my video. If something is not clear for you, let me know in the comment. I'm happy to answer any questions and explain any piece of code. And next video, we are going to create our own database. Using this data, we will create our new database, create new tables. I will show you how can you done with script. Then we will just, go to command prompt and run those scripts. It will create the database, then create the tables, then send to, we will create an ETL process and fix the data and send those data to our database. After that, then in that database, we will create views. I will show you the performance differences between views using all the tables in your Power BI application, and we will create a very cool dashboard. And then, yes, and then you will see the performance difference as well. Thank you so much for watching my video. Hopefully everything is clear, and just leave a comment, and I will make clear some if some things are abstract. And thank you so much for watching my video.